Marhaba. Okay, in this session we want to use matrices, in particular Boolean matrices, to represent relations. Okay, remember a Boolean matrix is a matrix whose entries are either zeros or ones. Okay, so let me start by an example before we give the definition. Suppose we have the set A, and A contains the elements 1 and 2, and we have the set B, which contains the elements A, B, C. Okay, and suppose we have a relation R from A to B. So we have a relation. What's a relation? It's a subset of A cross B. So it will be a set of pairs. So the pairs are 1A and 1B and 2B, okay, and 2C. So these are the elements of the relation R, and notice this R by definition it's a subset of the Cartesian product A cross B. Now we've seen that we can represent this relation by a directed graph by arrows, but now we want to use matrices to represent this relation. So we will call the matrix M sub R. Okay, so this is the matrix representing the relation R. How we will do this? It will be a matrix of size 2 by 3. Why 2 by 3? 2 is the cardinality of A, which will be the number of rows of the matrix by 3 columns, where 3 is the cardinality of B. So we want the rows of the matrix to be represented to represent the elements of A, and the columns of the matrix to represent the elements of B. Okay, so I'll make this clear now. So let me use green. So the first row represents the relations of the number 1, and the second row represents the relation of the second element in A, 2. Notice here the matrix depends on the enumeration, on the listing of the elements of A and B. Now the first column will represent the first element of B, which is A, and the second column will represent the second element of B, which is B, and the third column will represent C, the third element of B. Now, how we will proceed? If 1 is related to A, then we will put 1. So since 1 is related to A, we have a 1 here. Is 1 related to B? Yes, it is. So 1 is related to B, so we put 1 here. And 1 is not related to C. Why? Because, so notice that 1 is not related to C because the pair 1C is not an element of the relation R. R is a set. It has 4 elements. So we put 0. So if 2 elements are related, we put 1. If 2 elements are not related, we put 0. Now let's check for 2. 2 is not related to A, so we have a 0 here. 2 is related to B. Here it is. So we put 1, and 2 is related to to B and C, so we put 1 and 1. Okay, so this matrix, you see, it's a 2 by 3 Boolean matrix, okay, which have the information of the relation. Okay, so from the matrix we know the relation. Okay, if you want, we can do it quickly. That here we can draw the directed graph diagram. So these are the elements of A, and these are the elements of B, and from here we know 1 is related to A, and 1 is related to B, and 1 is not related to C. 2 is related to B and C. So 2 is related to B and C. So so you see how many ways we have to represent a relation. So here is 1 by writing the set, or we can use a matrix, or we can use a directed graph. So, okay, directed graph. So all of these are 3 different ways to represent relations. So let me now, using this example, formalize the definition of what we call the Boolean matrix representing the relation R. Okay, so how do we start? So suppose we have a set A of cardinality M, and we need to fix a listing of its elements. So say A1, A2, A3 up to AM. So we have, this is A, and we have B and of cardinality n, so B1, B2 up to Bn. So we start with two sets, and we also have a relation which is a subset of A cross B. We are given, so we are given all of these. We are given a set A, a set B, and a relation. Okay, so R is a relation. It's a subset of A cross B. Okay, then we can define what is called the Boolean matrix, representing, okay, the matrix, the M by N matrix. Okay, notice that M is the cardinality of A, it has M elements, and N is the cardinality of B. So the M by N matrix representing the relation R is the following matrix. It's M sub R, whose entries are denoted by small mij. So remember from matrix notation that mij is the entry in the matrix which lies in the ith row and jth column. So I is for rows and j is for columns. Okay, so this is the matrix. Now I want to tell you what are the entries where mij. So what is Mij? Mij is equal to 1 if the ith element of A is related to the jth element of B. So if AI is related to BJ, and it is 0 if the ith element in the set A is not related to the jth element of B. Okay, this is what we did. So you choose here AI and you choose here BJ, and if they are related in the relation R, so this means, okay, so note what does this mean? That the pair AI BJ is an element of the relation R. So this is the meaning of AI related to BJ. If this pair belongs to the set R, the relation R, then we put 1 in the ith row and the jth column. If not, we put 0. Okay, so let's take another example, but in the reverse direction. So suppose we are given a matrix and we want to obtain the relation. So suppose our set A, its elements are listed as alpha, beta, gamma, and our set B, its elements are listed as A, B, C, and we are given the matrix representing some relation R. So notice that this matrix should have size 3 by 3. It should be a square matrix, and the matrix you are given is 0, 1, 0, 1, 0, 1, and 1, 0, 1. Okay. Now what does we need to obtain R? What is R? What is the set R, the relation R? Okay. We know that the first row represents alpha, the second row represents beta, and the third row represents gamma. And the first column represents A, the second column represents B, and the third column represents C. Okay, so from the first row, we know that only alpha is related to B. So the pair alpha B is in the relation. Now we look at the ones. From the second one, we know that beta is related to A, right? Because we have a 1 here and a 1 here. And beta is related to C. And from the third row, we know that gamma is related to A, and gamma is related to C as well. Okay, so this we obtained R, and notice that this R is clearly a subset of A cross B. Every pair in R has its first term from A, alpha here, and second term B is from the set B. Okay, so notice when we have a relation, now let me say a few comments when we have a relation on a set A. So suppose A has a cardinality n, and we have R a relation on A. So this means that R is a subset of A cross A. By definition, this is the meaning of a relation A. It's a relation from A to A. Okay, then MR will be a square matrix. MR is a square matrix. Okay, it has it's n by n, right? Where n is the size of A. It has n rows and n columns. Now, look at these comments. Remember, we defined what does it mean for a relation to be reflexive if every element in the set is related to itself. So what does it mean that R is reflexive in terms of the matrix? So R is reflexive. So this is observations. R is reflexive if and only if every element, so say A is the set A1, A2 up to AN. So R is reflexive is if A1 is related to A1 and A2 is related to A2 and AN is related to AN. So this means that the diagonal matrix elements are all ones, right? So if and only if all the diagonal entries, main diagonal entries, okay, all the diagonal entries in MR. What is MR? It's the matrix representing R, are all ones. Are all ones. So this will be the form of the matrix MR if the relation R is reflexive. Then we have 1, 1, 1 on the main diagonal, and we can have anything you want off the diagonal. So I'll just put stars. You can have zeros or ones, it doesn't matter, but what matters is that what matters is that the main diagonal, has all ones. Why is this? Because what does it mean that we have 1 here? What is this one? It means that A2 is related to A2. Right? This one is M22 and it's equal to 1. So the entries, so we denote the entries by Mij, and this is the matrix. What is this entry? It belongs to the second row and second column. So this is M22 is 1. But when M22 is 1, if A2 is related to A2. Remember, the first row represents A1, A2, A3 up to AN, and then since it's a relation from A to itself, then the first row also represents A1, A2, A3 up to AN. So what does this one mean? It means that A3 is related to itself. This one means that A1 is related to itself. So every element in A is related to itself, which means the relation is reflexive. Okay, now what is the form of the matrix when the relation is symmetric? So R is symmetric. Remember, what does symmetric means? If one element is related to another element which may be equal to it, if first element is related to a second element, then the second is also related to the first. So R is symmetric if and only if whenever an entry Mij is equal to 1, so when the ith element is related to the jth element, then actually if and only if mji is also 1. So if the ai is related to aj, then aj is related to ai as well. Okay, and so this means, so if and only if the matrix is the matrix MR is symmetric. Remember how did we define a matrix is symmetric? If its transpose is equal to itself. And we've seen that symmetric matrices are symmetric across the main diagonal. So if this is MR and this is the main diagonal, okay, the main diagonal could contain ones or zeros as you wish, but if there's a 1 here, there must be a 1 here, because what this one means that AI is related to AJ. And this one's, so there's an arrow. So there is an arrow from AI to AJ. But since the relation is symmetric, then there must be another arrow from AJ to AI, which means that we should have this one, which relates AI with AJ as well. Okay, so this is the jth row and this is the ith row, and this is the jth column and this is the ith column. Okay, and if we have a 0 here, then its mirror image should be 0, because if we don't have an arrow and the relation is symmetric, then there shouldn't be an arrow in the reverse direction. Okay, so this is the picture of a symmetric matrix representing a symmetric relation. Whenever you have 1, its mirror image is 1, and whenever you have 0, its mirror image is 0. Because otherwise, if you have 1 and its mirror image is 0, then this means we have an arrow and we don't have the reverse arrow. But this violates symmetry of a relation. A relation is symmetric if whenever AI is related to AJ, then AJ is related to AI as well. Okay, and finally, let me say what is the form of R being antisymmetric. Okay, antisymmetric means that if two distinct elements and the first is related to the second, then the second is not related to the first. So R is symmetric if and only if whenever we have two distinct elements and AI is related to AJ. Okay, this means that MIJ is 1. Okay, then MJI must be 0. So it means if AI is related to AJ and AI and AJ are different, then there should not be a reverse arrow. This is, you need to see antisymmetry definition. Okay, so what is the form of this matrix? So what we described is, this is the main diagonal. So I is not equal to j. This means that the ones are not on the main diagonal. So if you have 1 here, then its mirror image should be 0. Okay, if this is the ith row representing AI and this is the jth column, then this means that the jth element is not related to the ith element. Okay, and similarly, if we have 1 here, then its mirror have to have 0. Its mirror image should be 0. And okay, there's no problem to having 0 and its mirror image is 0, because this case means that we have 2 elements and nobody is related to anybody. It's not a problem. Okay, remember, antisymmetry means whenever you have an arrow. So why 1 means an arrow? Because it means that this element is related to this element. So if this happens, then so suppose this is the element A and this is the element B, then this means that A is related to B, but then B should not be related to A. So this means here is B, and here is A. This means that we should not have an arrow from B to A. So here it should be 0. Why is this? Because it's antisymmetric. Antisymmetric, if two elements are different, one is related to the other should not be related to the first. Okay, so let me just quickly summarize all of these ideas in one. Suppose we are given this matrix. So it's 1, 1, 0, 1, 1, 1, and 0, 1, 1. Okay. What can you tell about this relation? Okay, first you need to look at the main diagonal. So here is the main diagonal. Since, okay, maybe here you can think of any set of 3 elements, say A, B, C, and R is a relation on A. So it's a subset of A cross A. So the first row represents A, the second B, the third C, and the first column represents A, B, and C. Okay, since the main diagonal is ones, are all ones, then A is related to A, B is related to B, C is related to C. So we know that this relation is reflexive. This is 1. Second, since the matrix itself is symmetric, right? Look, 1, its mirror image is 1, 0, and its mirror image is 0, and 1, and its mirror image is 1. Okay, this means that the relation R is symmetric. Okay, look at this 1 and 1. This one means that B is related to A. So since it's symmetric, we should expect that A is related to B, but here is A is related to B. See, A is related to B, and so on. Finally, it is not antisymmetric. And why is this? Because antisymmetric means if you found a 1 of the diagonal, so look at this one, its mirror image should be 0, but its mirror image is also 1. So let's see, what does it mean? What are these two ones represent? So this one represents that C is related to B, right? If, for the sake of contradiction, the relation was antisymmetric, since C and B are different, then we should not have an arrow. So we expect the entry representing, say, I will call it BC, should be 0. But where is the entry BC? It's this one. Here is B, and here is C. Okay, so we expect this to be 0, but it's 1. And so it can't be antisymmetric. Antisymmetric means whenever you have 1 of the diagonal, its mirror image should be 0. Okay, so we can read properties of the relation from the matrix representing the relation.